Hi there. Okay, so we are on our last booklet, chemistry booklet number 4, and this is where we're going to take a look at the different types of equations, and we start to pull all the different stuff that we've learned in chemistry together. So I hope you watched the first video there where they give some different examples about the different types of equations, and I'm just going to go through in your booklet how to fill it in. Okay, so first off, synthesis reactions. Okay, so synthesis means to put together. Okay, and the key for a synthesis reaction, or how you can tell, is that it only has one product. Okay, so in the video they use the example of AB makes AB. So you have your first reactant, then you have your second reactant, okay, and then together they make a product. One product, just one product, okay? So, for example, we have calcium and sulfur, okay? And we can do these ourselves, okay, because we can figure out the charges, right? So the charge for calcium is +2. The charge for sulfur is -2. When we crisscross and combine and drop the positive and negatives and reduce, we are left with CaS, okay, calcium sulfide. Next one, we have hydrogen and oxygen, okay? And we know that these are diatomic molecules because whenever they're by themselves, there's always two of them. Okay, we know the charge for hydrogen is +1 and the charge for oxygen is -2. So when we crisscross and combine, we get H2O. Okay, don't worry about the subscripts here. Okay, that's just for this molecule. When we combine hydrogen and oxygen, you just have to look at their charges. Okay, so see, two products or two reactants, one product, just one product. Okay, that's synthesis. Decomposition. Okay. Oh, before I go on, the next thing you do before you finish is you always balance your equations. So C plus S gives us CaS, so that's balanced. So then I would just put a 1 in front of everything. Okay, here I have H2 plus O2 gives me H2O. Okay, well I need a second one, 2 O's. Yeah, so I need a 2 here. That gives me 4 hydrogens. I'm going to change that to a 2 to get 4 hydrogens, 2 oxygens, 2 oxygens. So I'm good. Okay. See, we're taking everything, our ionic bonding, we're putting it all together, and we're using it all at once. Okay. Next one, what is decomposition? Well, if you think about decomp, okay, to break apart. Okay, when something decomposes, it's rotting in your backyard, right? It's breaking apart. Okay, so here the big key is you look for one reactant. If it has one reactant, then you know that it's going to decompose. Okay, so here I'll just draw 2 items, or sorry, 1 item, and then it's going to break down into just a circle and just the triangle into 2 products. It can be more than 2 products, this just happens to be 2. Okay. Okay. Let's take a look at our examples. C2H6. Now, what do I notice about these two? Okay, well, carbon is a nonmetal and hydrogen is a nonmetal. And so this is just going to simply break down into carbon and hydrogen. Okay, and of these two, hydrogen is diatomic, which means we have to add the little 2 there. Okay. But there's no subscripts for carbon, and then we can balance. Okay, so I'm going to see I have 2 carbons over here, so I'm going to have to put a 2 in front of the C. And I have 6 hydrogens, but I already have 2, so 2 times 3 is going to give me 6. Okay, then I can put a 1 in front. Okay, there we go. So that's breaking down C2H6. Okay, and here let's take water and do the opposite. Okay, so water is going to break down into hydrogen and oxygen. Both of these are diatomic. Okay, so when they're by themselves, there's always 2 of them. Okay, and the last thing we want to do is balance the equation. Okay, so we have 2 oxygens here, so we need a 2 in front of H2O. Now we have 4 hydrogens, so we'll add another 2 here, and we're done. So we can add a 1. Okay, remember to always put a 1 coefficient when you're balancing and you're finished. Done. So that is synthesis and decomposition. Turn the page. Single replacement. Okay, so single replacement means that one element in a compound will replace one element will replace another in a compound. Okay, and in the video you watched just before this, the example they gave is that it's normally a metal, right? Which would make it a cation. Okay, so either swap the positive ions or negative ions. Okay, you just have to take a look and see what you got. Okay, so for example here, grab all my different pens here. So if I had a circle and a compound, okay, now if our circle was the positive charge, okay, and here's our compound, so that means we're going to have a positive and a negative, that would mean the circle and the triangle would change. Okay, so now the triangle would be by itself, okay, and the circle would form a bond with a square. Okay, so all you're doing is changing the similar sign. Okay, if the circle happened to be negative, okay, then you would swap the negative one. Okay, then you would have, oh sorry, this would be negative, and then this would be positive and negative, I think. Yeah, so if you have 2 positive ions, you're going to swap the cations. If you have 2 anions, you're going to swap the anions. Okay, so let's try some actual examples. Okay, here we have zinc plus hydrogen chloride. Okay, zinc is a metal, so it's going to have a positive charge. Hydrogen also has a positive charge, and chlorine has a negative charge. Okay, and what exactly are their charges? Oh, forgot my periodic table. 2 seconds. Okay, charge for zinc. Where is zinc? Zinc is metal. Ah, here. Charge for zinc is +2. Okay, charge for hydrogen is +1. And the charge for chlorine is -1. Okay, so I'm going to swap the hydrogen and the zinc. Okay, so now I'm going to have hydrogen by itself. Okay, and then I'm going to have zinc chloride. Okay, So to make this easy, I'm just going to swap all the elements first and write them down, and then I can do the proper combining afterwards, right? So zinc has a charge of +2 and chlorine has a charge of -1, right? So I'm going to bring the 1 down here, which I don't have to write, and the 2 down here. So you have ZnCl2. Okay, get rid of that. And hydrogen is diatomic, so we add the little 2. And last but not least, we balance. So let's see, I have 2 hydrogens, only 1 here, so I put a 2 in front. I have 2 chlorines, 1 zinc, 1 zinc. The rest of them are good. Now look at this, we're using all of our chemistry all at once. I love it, okay? Take a look at the next one. We have magnesium and calcium nitrate, okay? The charge for magnesium is +2, okay? Charge for calcium is also +2, okay? And the charge for nitrate is -1, okay? And where do you find that? You look on your bigger periodic table that, or the bigger page you got. It has all the different lists, and on there is a list for the charge for the nitrate. It's also in your notes as well. Okay, so now we can see these are the 2 positive ones. That's what's going to switch. Okay, so now calcium will be by itself. Okay, and now magnesium is going to bond with nitrate. Okay, so I don't bring any of the subscripts. I don't bring this 2 over because that's just for this bond. Okay, but I do bring this 3 because nitrate is NO3. Okay, calcium is not diatomic, so that's good by itself. Magnesium is +2, nitrate is -1. 1 goes down there, so that's okay, and then the 2 comes down here. And then I can get rid of this on top. Okay, and then we'll balance and make sure we have everything okay. 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium, 1 calcium, and calcium. Okay, so 1's all the way around. Okay, and the last one is sodium and water. Okay, so sodium, the charge for sodium, I'll go to my periodic table. Sodium is in the first column, so its charge is +1. We know the charge for hydrogen is +1, and oxygen -2. 1, 2. Okay, so we can see again we have 2 cations, so we're going to swap those. So now hydrogen will be by itself, and sodium is going to mix with oxygen. Okay, remember hydrogen is diatomic, so we add a little 2. Okay, and the charge for sodium was +1, oxygen is -2. So when we crisscross and combine, the 1 goes after the O, so that's okay, and then the 2 comes in between here. Na2O. Okay, and our last step is we just balance. I'm going to get rid of this stuff here. So you have 2 sodiums, so we'll add a 2 on this side. Okay, 2 hydrogens, 1 oxygen, 1 oxygen. Right on, so the rest is good. Okay, so look at this. You're practicing ionic bonds, you're practicing types of reactions, and you're doing balancing equations all at the same time. Okay, I love this. Okay. Okay, last one is double displacement reactions or replacement reactions. Either one works. Okay, they both mean the exact same thing. Okay, so what does this mean? It means that 2 compounds exchange their, we'll say they're anions. Okay, they're pretty much just switching partners. Okay. So if I were to draw this out, how do I want to do this? Let's do this. Okay, so if I had compound number 1, I'm gonna make this a circle and a cross, and then I'll have a triangle and a square. And I tried to make my cations blue and then my other ones green. Okay, so now we're gonna keep our cations in the same place. And we're just gonna swap the other partner. Okay, so we're gonna, now the square will be with the cross and the circle will be with the triangle. Okay, so this was positive and negative, and now we have made 2 new complete compounds on the product side. Okay, it really doesn't matter whether you swap the cations or you swap the anions. Just don't do both, otherwise you'll end up with the same thing. Okay, so I just keep the cations in the same place and I swap the backside. Let's give it a try. We have HNO3 plus NaCl. So if I look at this compound here, hydrogen nitrate, here is a polyatomic ion. So I'm just going to put that in a bracket so I can keep track of it. So hydrogen is my positive charge, nitrate is my negative charge. Sodium is my positive charge, chlorine is my negative charge. Okay? So I'm going to keep my cations in the same place. So hydrogen, okay, and now sodium. Okay, and now I'm going to switch those ones. Okay, so now it's going to be HCl and NaNO3. Okay. Now the charge for hydrogen is +1. Charge for chlorine is -1. So when we crisscross and combine, this is good. HCl, that's good. Charge for sodium is +1. Get rid of that. Charge for sodium is +1. Charge for nitrate is a -1. So we crisscross and combine, same thing. Get rid of that. Last thing we do is put a 1 in front. Okay, because everything is balanced. Excellent. And last one, we have calcium oxide plus aluminum chloride. Calcium is our cation, oxygen is the anion, aluminum is the cation, chlorine is the anion. Okay, so I'm going to keep my cations in the same place. Okay, so I'm going to have Ca and Al. Okay, they're often metals. Okay, they're often, but sometimes they're not. So you have to be careful. So Ca and Al. Now I'm going to swap these ones. So now I'm going to have CaCl and AlO. Okay, now to make sure we've got it right, let's check our charges. Charge for calcium is +2. Charge for chlorine is -1. So when we crisscross and combine, we're going to get CaCl2. Okay. Charge for aluminum is +3. Charge for oxygen is -2. So when we crisscross and combine, we're going to get Al2O3. Okay, excellent. Now let's just balance. Okay, we have 1 calcium, 1 oxygen, 3 oxygens. Okay, so I'm going to have to put a 3 in front of here. Okay, so now that I've done that, my calcium is now 3, so I'm going to put a 3 in front here. So now I have 3 calciums, okay, 3 oxygens. I have 1 aluminum here, but 2 aluminums here. So I'm going to have to put a 2 here. Now I've got 6 chlorine and 6 chlorine. Ah, we're good, okay? And add our 1 when we're done, okay? Okay, so if you're like, how do I know what to do? What is going on there? Okay, so the first step is I write down the cations. Step 2, I put the anion with the new partner. Okay, step 3, determine charge of new product. Okay, so that's where we wrote the charges up here, and then crisscross and combined. Okay, and then 4, crisscross and combine. And then step 5, balance equation. Okay, so that's just kind of a quick overview of how you do double replacement. Okay, turn the page. Okay, so here's a quick summary, right? When we're looking at synthesis, we have A plus B gives us AB. Okay, so here we have 2 or more reactants that produce one product. Okay, so Na plus Cl would give us NaCl. Okay, when you check your charges, charge for Na is +1, chlorine is -1, crisscross and combine, and you're good. And then we go to balance, you have 2, 2, 2, and 1. Okay, decomposition. One product breaks down into more than one, one reactant breaks down into 2 or more products. Okay, one reactant breaks down into 2 or more products. Okay, so here we have potassium chlorate, and this would break down into potassium chloride plus oxygen. Would you know this? No. Could you figure this out on your own? No. No. So don't worry about that. I will not give you anything that you can't do on your own. Okay. We have 3 oxygens. We have 3 oxygens here and 2 oxygens here. So I'm going to make this a 2 and this a 3. Now I have 6 on both sides. Okay. And I have 2 potassiums and 2 chlorines, so I'll put a 2 there, and we're balanced. Okay, single replacement. We have one element and a compound produces a new compound and a new element. Okay. So if we have magnesium and hydrogen chloride, okay, so we're going to swap these two. Magnesium is a positive charge, so is hydrogen. So hydrogen will be by itself, and magnesium will now be with the chlorine. Okay, hydrogen is diatomic, so we have the little 2. Magnesium's charge is +2. Chlorine's charge is -1. We crisscross and combine, we get MgCl2. Okay, and when we go to balance, we have 2 chlorines, so we have to have 2 on the reactant side, 2 hydrogens, 1 magnesium, 1 magnesium. Right on, so the rest are all 1s. Make sure you pause and try this stuff out yourself, okay, and then check your work and see how you did, okay. And the last one, double replacement, PQ plus RS gives us PS plus RQ. Notice how we kept the cations in the same spot and we just swapped the second part. Okay, so we have compound 1 and compound 2, and that gives us compound 3 and compound 4. Okay, so this one you can also figure out on your own. NaNO3, there's our polyatomic ion, whose charge is -1. Okay, so we have +1, -1, +1, and -1. So what should be the new product here? Okay, so we're going to keep our cations in the same place and switch the back side. And then let's balance. Well, hold on. +1 and -1 crisscross, that stays the same. +1 and -1 crisscross stays the same. So these are already balanced. Right on. Nice job. Turn the page. Okay. Can you tell me if these are synthesis, decomposition, single displacement, or double displacement? Okay, give them a try. The first one here is a yes, right? Synthesis, there's only one product. Okay, next one. What do we got here? Double displacement, okay? One compound, two compound, new compound, new compound, okay? Next one right here, okay? Decomposition, only one reactant, okay? Next one, look at this. Only one product, so that's an S. Another one, only one product, that's an S. And our last one, we have an element, compound, makes a compound plus an element. Okay, so this is single displacement. Right on, awesome job.